Hey guys, and welcome back to my level creation self challenging Unity video collection. In this video, I am going to do my improvements for the first person character object so that I can move on to the level creation step, which is the actual intention of this video set. It's better to have a single variable to control the movement speed instead of having two speed variables. So let's make one movement speed variable and then refer them in our update method. Okay, now we have a simple behavior to move the player object along the x-axis and z-axis, but still this object can't take turns or turn around and walk to a different direction. For an example, let's say I want this object to move along its local z-axis. So whenever this object is rotated, it aligns its movement aligns with its own z-axis. But still, it's not happening in our behavior. It just uh, moves along the global x-axis and z-axis, not the object's local axes. So if I can access the local transform position vector of that player object, then I can scale each component with the input values, horizontal input and vertical input, and then we can obtain the final movement vector with the consideration of the player's rotation. So let me delete these previous two lines. So we have a horizontal input value and a vertical input value. So basically we figure out a resultant vector including these values and scale it with a certain multiplier, which is the movement speed, right? Yeah, so the calculation should basically look like this, but we have to add more components here. So let's see how to access this local transform of our player object and assign these values here. You can type transform and access these x-axis and the z-axis that are local to this player object. So we can type here transform dot uh, forward and transform dot right. Uh, okay, I think this one is better to be right because we are taking left right input from the horizontal input. So transform dot right with the horizontal input, and let's copy it and paste here. And now for the vertical input we multiply it with the transform dot forward. Okay, Okay, so let's assign a value for our movement speed and go back to our editor. Let's fold out these components. Okay, but the movement speed here has 0. I think we have to assign this variable in a different way. Okay, let's just try it as a private variable. Okay, right. Okay, so now we have the movement just like before along the axis. So what if we rotate this from our editor? Okay, now let's go forward. Right. Okay, it went outside. Oh, now you can see that our movement method is actually considering the rotation of this player object, because we are scaling the input values along the transform.forward and transform.right axis. There is one more thing that we need to add to this movement speed. It is to scale this movement with the delta time between frames, so that our movement becomes independent of the frame rate of our game. Okay, so now basically you can see that our update loop or the update method has three sections, where the first one takes the input from our player's input device, and there's another section that processes these input values and do some calculations, and then we make a certain output using that processed values. Okay, now that our player character moves with considering the turn direction, now let's add another feature for this movement behavior, which is falling from heights. Let's say the player character is on this cube, and in our play mode we can see that this character is not falling down. So that's the feature we need to implement in our player script. For that, let's add some floating point values. Let's define the gravity or gravitational acceleration and a falling speed. We can make use of the character controllers is grounded boolean state to read the player's current position, whether it's on the ground or whether it's in the air, and calculate the falling velocity and include it in our movement vector. So let's make a condition: if the character controller is on ground and if it is not on ground. So this is the basic two states the first person character should be at. It should be either on ground or not on ground. Okay. So if the character is on ground, let's find it by character dot is grounded, which is the property that I talked about that's included in the character controller. So if that state is true, then you can keep it as stay grounded, right? Which means the falling speed is 0. And if not, you have to make it fall down, which means the falling speed has to increase downwards in the acceleration rate. And just like before, to make our change of falling speed independent of frame rate, I am scaling the gravity value by the delta time between frames. And now we have a falling velocity, but we don't know along which direction should this falling velocity align, so that we can assign this resultant vector into this movement vector. So let's go back to our editor and see. Here in our player character, we already know the forward and right axis or directions, and this green arrow is the direction the player should fall. Basically, in other words, the negative direction, right? The negative y direction should be the direction the player should fall. Since we have time dot delta time in our movement vector calculation, I don't need that here. Let's delete that. And in our movement calculation, let's access this direction as transform dot up and multiply this fall speed along this transform dot up vector. Okay, now the falling direction or falling vector is added to our overall moving vector. Now we can make the entire value set independent of frame rate, and let's see our play mode. Okay, now it's falling down properly from our height. And additionally, let's try keeping the player character on air, and okay, in play mode it falls down correctly, right? Now that we have a decent movement behavior for the first person character, let's prepare this first person view for the character. So I am selecting the player object and go to game object and align view to selected. When you select it, your editor view switches to the player object, and then you can select the main camera and go to game object and align with view, which means this camera object aligned with the current view of the editor, right? So now we easily have made this camera align with our player's forward direction as well. Now if we make this camera a child of this player object, then all the rotation and movement will be followed into the main camera as well. So now if I rotate the player object along the y-axis, you can see the camera is rotating as well because it's a child. And when I rotate it along the x-axis, the camera rotates as well, but the player object also rotates, which is not a natural, which looks quite unnatural. So let's try another way. So what if we rotate the player character around the y-axis, and then we can rotate the main camera around the local x-axis, or the camera's local transforms x-axis. Then it would look more natural. So let's try making this behavior in our code. So I have added two floating point variables, mouse x, mouse y. These variables are to read the mouse input or the mouse movement so that we can calculate the movement of the first person camera and first person characters turning angles. And additionally, let's keep a vector 3 variable for the looking direction or the direction of the camera, and assign it with the 0 vector. And another vector 3 for the player character's turn or the turn direction, and keep it as a 0 vector. Right. Okay, let me remove those. Okay. Right. So I'll comment the description as well. So the look vector is to look up and down or turn the camera up and down, and the turn vector is to turn the player left and right. I think you can understand the purpose of these two vectors. Okay. Okay, so now we need two floating point values or two fields to calculate the rotation amount or angle around different axes that we are rotating this player and camera. So if we go to our editor, you see that if we turn the player character, there should be a value around the y-axis. The rotation amount is going around the y-axis, and for the camera this value is going around the x-axis. So let's keep these values in those names. Let's make a variable called x rotation and keep it 0, and another floating point as y rotation with 0. Okay. So this x rotation is the up down amount, and the y rotation is left right rotation around the y axis. Okay. Now let's read our input values and assign them to our mouse x, mouse y variables. So you can again use the input class and get the getAxis method and pass mouse x to retrieve the mouse input values along the x-axis. And for the y-axis, again we can use the getAxis method and pass mouse y. Let's check these two values with the debug call in the next line. So let's go debug.log and pass these two mouse y and mouse x values. Okay, mouse x, and check our editor to see what we get as these values. Let's go to play mode. Right, you can see in our console we are getting some values according to the movement of the mouse. Right, so now we can use these mouse x and mouse y variables or the values assigned to them and process to calculate the final look vector. Before calculating the look vector and the turn vector, we will have to use the mouse x and mouse y values to process and get the rotation values around the y-axis and x-axis that we are considering in the current scenario. So first let's calculate the y rotation. Here I am directly adding the mouse x value to the y rotation and the mouse y value to the x rotation, because when we move it forward and backward, the rotation should be around x-axis, and when we move the mouse left and right, the left-right rotation should be around y-axis. So that's why we added these values to the considered variables in this order. But if we go back to our editor, so there is no output because we are not referring the camera or doing anything to the camera and player using these values. So let's go back to the code editor and keep going on with the calculations. So I am trying to make a look vector by assigning the two rotation values to the variable that we already have. So let's assign the y rotation to the look.y, and for the look.x we can assign the x rotation. Okay, now we can access the transform of the player object by the transform, and we can assign this vector for the Euler angles property. So now in our editor, let's go to play mode, and you can see with the mouse movement the camera moves too, but the player object also moves with the mouse, so that's not the intended behavior. So let's try again. Let's keep a reference to the camera object and try accessing it in our code. Let's make a public transform variable as cam, and here instead of the player's transform, let's assign this to the camera's Euler angles property. And let's go and play this again. Okay, we are getting unassigned reference error. So we have to assign this camera into our inspector field. So we drag this camera object to this cam field in the player script. Okay, now right, we can see the left right turn seems okay, but looking up and down is inverted. So instead of adding the X rotation, we can do the opposite, and we can get the expected outcome for the up and down look directions. Okay, but now still okay, the camera doesn't stop when you look up. The more you move the mouse, it goes and turns back to your head. That's not natural, so we can clamp this X rotation between a minimum and maximum value using mathf.clamp. So this method requires a minimum value and a maximum value, and the outcome will be limited between these two min and max parameters. For now, I am going to clamp this X rotation between negative 90 and positive 90 so that the rotation value doesn't exceed those two values. So I am passing X rotation, and let's go with minimum as negative 90. And the maximum as positive 90. Okay, so now let's go back to our play mode here. So when we look up and keep looking up, the camera stops at the intended angles. Alright. We can even pass different values as we want and check and come to a proper minimum and maximum limits for this up and down limit. So now I need the method to turn the player character left and right. For that, let's use the Y rotation value and try assigning it to the turn vector that we previously created. So we already have this look.y. So what if we do turn.y as the y rotation? And here let's try to access the transform to get the player's transform and get the Euler angles and assign the turn vector. So let's try and see what happens in the play mode here. Yes, the player is rotating. You can see the local directions are turning in the scene window, but the camera is still not behaving in the expected manner. So we have to do more work here. Okay, so in our play mode, this movement seems proper good enough. So let's try making duplicates of this cube so that we can get a clear shot of this environment. Okay, and right, so let's try go to play mode and maximize the window. Okay, so the look behavior seems decent enough, but still I think we have some improvements to be made because the camera movement is kind of choppy for me. But first let's try giving two look speeds so that we can control the horizontal look speed and the vertical look speed. We can even customize these values later if needed. So it's better to have these variables at hand. Right. I'll keep them as 1 here, and in our calculation part you can multiply these mouse x or input values from the variables that we already created. For the horizontal look speed, I am multiplying it for the mouse x, and for the mouse y I am multiplying it with vertical look speed. Okay. Okay. Now I think this is a good time to think about reworking the camera movement. Now that we have a movement that is taking the mouse input, let's try rearranging this code properly. So let's try removing this look vector using the y rotation. And okay, I'm going to do a proper order for these executions. So now the turn vector is calculated using the y rotation, and the player's transform dot Euler angles get assigned with the turn vector, and for the look I'm taking the x rotation. Now I can use transforms local Euler angles property to access the local transform of the camera and assign the look variable to that vector. Okay, so let's go back to our editor and go to play mode. Okay, I think the turning of the camera seems a little bit smooth than the previous attempt. So I'm quite happy with the outcome here, and the movement is going accordingly as well. So I think this is okay for this camera's turning behavior. Okay, so our first person character controllers movement and look around behaviors have come to a functioning state. There is one more thing that I need to address before closing off this video. So I am back in our example scene or the test scene, the object that we used to detect the keyboard input. You can see that if I press and hold both up key and right key, the keyboard object is snapped to the top right corner of our square grid. But if I press only the right key, the square or the object snaps to the right edge of the square grid. So if the player object is moving in diagonals, then the distance traveled per frame call is larger than the distance traveled when you are going forward or right. So the speed of the player object will change when you keep trying to move diagonals and then go back forward. So this change of speed is not natural. We can easily address this issue in our code. We can normalize our movement vector so that regardless of the direction, the resultant vector is a value between 0 and 1. Then this extra value that we get when going in diagonals gets reduced to 1. Now if I press multiple keys to move this object, you can see the distance towards the object from the center is always 1, forming this circle. So let's go back to our original scene and edit our player script to add the normalized property to the movement vector. Okay, so let's go and open the script in Visual Studio. So we have a movement vector calculated which has all the transform directions up, right and forward scaled with the input values and passed to the character's move method. Let's try normalizing the movement vector when it is getting passed as a parameter to the move method. So you can put normalized here so that the movement vector gets normalized before getting executed in the move method. Okay, now let's try going to play mode. Okay, now the movement seems ideal because the forward movement and diagonal movement gets the same speed. But in this case, we are normalizing the falling directions speed as well. So it's better if we can use this normalized property only to the vector that is calculated to get the x direction or the x-axis movement and z-axis movement. So we can normalize only that part here. So we have a vector that is the addition of transform dot right and transform dot forward. So we are normalizing that vector only, and now the falling speed is not getting affected for this normalized property. Okay. Okay, with that, my implementation of the first person character is complete. Let's try it again in our play mode. Okay, now the movement is quite decent. So we will use this character to traverse around our level. I can keep playtesting my level using this first person character and keep redesigning the arrangement of objects in my level. So I am stopping my video for now. See you guys again in another video of this level creation video collection.